So I have the great pleasure of introducing Kevin Richards. Kevin is he's a special guy, right? He went to school at CCS. We hired him as an intern at Alias back in the late 90s, I think, right, Kevin? 98 or
That's right.
99, something like that. He was part of the DUA regime, right? If anybody remembers DUA, I think DUA was teaching at CCS and he tapped Kevin and said, yeah, this guy's really good. So we had quite a few good interns in the Alias offices, and we were constantly kind of growing resources. So, um, anyways, Kevin was joined us, and he worked for Alias, and then ultimately for Autodesk for quite a long time. I think even Kevin, you moved out to San Francisco, right?
That's correct. 11
Yeah,
years.
yeah. So he added tons of value. He was like the showcase guy for the longest time. I remember us talking about what Showcase was doing as far as a long, long time ago, as far as real-time visualization. And that was ultimately prior to Autodesk buying VRED and incorporating VRED into the tools and all that. So the beauty of Kevin's approach is he doesn't use just one tool, right? He's more utilitarian and he approaches every project kind of that way. He doesn't say like, oh, I'm going to use Alias and this is what I'm going to design. He kind of looks at it the other way around. This is what I want to design. And then I'm going to figure out the tools that I need to get things done. And that's kind of, just so you know, as far as when we look at resources to hire and what we're seeing is trending with our customers, more and more need by them to have utility players, people who are just not a good sketcher or an Alias tube jock or whatever. A wide variety of skills is trending, right? Because I think, with most of our car companies that we do work with, and mostly here in the States, every time we hear it, we have less budget. So we have to be super picky about who we hire. So we're looking for people who know Gravity Sketch or who know other tools like Blender and things like that. So any recommendation that I have for all of us here is like make sure that you embrace whatever tools are out there, right? I mean, not more so now than ever do we see that digital approaching design digitally is using a toolbox. You know, grab your toolbox, figure out what tools you need in it. I mean, there's not one way to do it. There's a bunch of different ways to get things done, but make sure that you have a toolbox of tools that allow you to do the things that you want to do. There should be no limitation anymore, right? So, anyways, there you go. So lately within Kevin's career, um, he did quite a bit of freelancing recently, and he's done quite a bit of training for us. He did this amazing sub D training class for us a while ago, which we still love. And Kevin was always an advocate of sub Ds, and I think you were quite involved in the development of sub Ds when you were at Alias and Autodesk. I mean, Autodesk, just so you know, had a bunch of tries at doing sub Ds, T-splines and all that, and it never really worked out. Only recently, with the most recent implementation of sub Ds, did they finally get it right. And it's not an easy thing to figure out, right? But having the underlying nerves on top of the sub Ds when you're modeling, and then being able to use that math data underneath is significant, right? So it's pretty cool. Anyway, so I'm going to turn it over to Kevin, and then just lastly here, real quickly, Kevin was at Waymo for I think 4 years, right, Kevin?
Yeah, it was just shy of 4 years.
Okay, and has chosen to continue to live this incredible life in North Carolina instead of grinding it out in the Bay Area. So that's I think what we're seeing also is still a desire for design resources to want to work remotely. Those jobs were more prevalent. There's fewer companies that are allowing remote work, which is really unfortunate because I think Alias or digital modeling is, I think, sometimes best done remotely. So you don't have all these studio nuisances and things like that. So we continue to try to convince our customers to allow the resources to work remotely, but sometimes there's just this mandate from management that, oh, you have to be in the studio. And so unfortunately, that's uh, kind of coming back to the way things are. But I think there still are opportunities, and we look for jobs for our people all the time who want to work remotely. So anyways, there you go, Kevin. I'm handing it off to you.
Awesome. Hey, thanks, Mike. Yeah, on that note, where I live in North Carolina is it's the home of NASCAR, and around here there's a lot of SEMA builds and a lot of these like crazy custom cars. So that's what's really exciting is it's a huge car community, and yeah, and I'm just really enjoying it. And that will lead us, let's see, let's share into the project and the stuff that I'm going to show. Can everybody see my intro screen? Just give you a thumbs up. Okay, excellent. All right, well, I'm Kevin Richards. That was quite an intro. Thank you, Mike. And let's see if I can, there we go. So let's start all the way in the beginning. So back in the early 90s, this stuff was probably in early 90s, 91, 92. I used to do a lot of special effects, and I got into just really being hands-on and always building something, checking out magazines at the time, and and just trying to do my own interpretation of that. I started getting into electronics and building, like on the lower right is a radio controlled full head. The skin and all the hair is decomposed over the years. That's probably over 30 years old now, but it's still functioning. And it kind of comes from my dad being a clay modeler at General Motors. I had access to clay. He was building funny cars, basically race car bodies in the garage. So I had access to a lot of materials such as, fiberglass. And that's where I really started getting into composites and to how things come together, how you build something and make something happen. I would collect and look through all these like horror special effects magazines. And at that time, if you see in the lower left where they start talking about Terminator 2 or The Abyss, they start talking about a software company called Alias. And between that and my dad at General Motors, that was my first introduction to Alias. And by the late 1999, July of 1999, I joined Alias Wavefront, and Mike Check was indeed my manager. Skipping ahead several decades, now I'm taking that and I worked for Waymo building these autonomous vehicles. Started off with the Jaguar vehicle, worked through the trucking group. I was the lead on on all of the CAD for that, and then ended up on the concept car and the future production car partnership with Zeekr. Waymo was a really unique experience because it combined automotive and consumer products. It was treated more of a consumer product. So, just the way parts came together, plastics, all the components in manufacturing seemed more like a consumer product, but yet we were doing aero studies, weather, all the sorts of things that you would have to do for an automotive surface. And that blend of components and formats was just really unique. And we got to explore a wide range of softwares and tools to do this stuff. And yeah, it was a great experience. But we're not going to talk about so much of the OEM stuff. A lot of you have seen presentations where I dive into the software and I demo. I've worked with many of you at the big automotive companies or in suppliers or concept cars and advanced cars. What we're going to talk about is a passion project that turned into, well, a whole nother path that I went down. So many years ago, when I went to dive in to really learn subdivisional surfaces, I worked for Foundry with Moto for a while. And during that time, I picked up a lot, but I had never completed a project. So I joined this, basically a user group, a forum for this car called the Superlight, SLC. And I started doing little modeling projects, and different, people that own these cars would post things and then I would model it. And I started doing custom parts for these cars and reimagining what you could do. So things like the brake duct inlets in the front, hood scoops. I've got molds for those and I can produce the parts or have the parts produced and be able to sell them to people. I really started diving into that with one guy where we're rebuilding the entire back of the car. He's just done a lot of work, and that got me into, fiberglass and mold making and doing it all myself. So not relying on basically the endless resources that we see in the big automotives, but what can I do in my garage? What can I do with friends and people that I know in the industry? As time went on, a company called Live to Offend, LTO, and Kaisel Salim approached me about doing their next gen BMW car. And this was really exciting. First of all, I'm sure many of you guys know who the Kaisa on Instagram is. He does a lot of slammed wide body vehicles and concept cars. Live to Offend, I was familiar with them because they had just debuted the E30 BMW, and it got a lot of press. Larry Chen did a whole video and write up on it and photo shoot. They were in the Toyo booth. They had all sorts of really cool stuff going, and they wanted to do their next vehicle. And it was an E36, so 90s BMW 3 Series. And Kaisel had these really cool renderings, really exaggerated details, but still all of the character of the original E36. And so that was basically the design mission, was to keep the essence of the E36 and just pump everything up, plus, plus. And so that's what we did. So over the next, COVID started happening at the end of it, so that slowed things down. But we basically were cranking out these models. And I'm going to take you through the story of how this car came to be, some of the challenges that we faced, and things that I used from my industry experience, and how we got scrappy to produce this car. Let's talk a little bit about this car. So as we were designing it, I wanted to keep as much of Kaisel's work as possible, and we'll take a look at the 3D CAD file here in a little bit. But he's a true artist. He cheats everything. So you bring it in. He doesn't really measure. He just eyeballs things. It's all look and feel for him. And so when we were going into production, there was a lot of interpretation, and that was very challenging. Working with somebody that has a vision and wanting to keep the essence of it, but also knowing what it requires to get a part out of a mold and where we needed to change things. The fitment of this was stellar. I mean, you can look on the left-hand side image, the fitment to the rear wheel, all of the detailing to the body. And we did this on a pretty low budget relative to what a lot of these cars end up. And ultimately, this car led us to SEMA. They had already been in SEMA, but this was my first real project that I owned that had not only one car, but 3 cars at one point in SEMA, along with 3 of the E30s. It was an insane year, lots of press, lots of people looking at it, and it was just a real honor to be part of that. Recently, this is the Tokyo Auto Salon, or this vehicle was launched in the Tokyo Auto Salon. We've done have such a reach with these body kits that there's now examples in all of Europe, in Korea, and now in Japan. There's 2 vehicles in Japan. I believe both of them came out this year that were built recently. So that's really cool that I can look at auto shows from around the world and see this body kit and see how those people interpreted what we did and how they modified it to make it their own. And basically, it was just me. At the end of the day, I was doing 90% of the footwork. Eric Penlow from LTO did more of the project management side of things, following up. And right from the get-go, we wanted to switch. They were building these kits in the US, in Pennsylvania. And this one, the goal was to build the entire project in China remotely. And so that was very new experience, working with a factory and multiple factories in China, looking to have different resources and all of it done remote. During that time, Kaisel works exclusively in 3ds Max, and he uses Corona render for all of his images. He would hand me off data in either OBJ or FBX to Alias. And keep in mind, this is pre-sub-Ds, like we're before the sub-D stuff really got going in Alias. So he was handing me a polygonal file that was more of a scan data type, is how I would use it and surface over top of it. And then I learned Fusion 360 in order to do all the final details that I'll take you through here in a second. The first challenge was we're using a handheld scanner plus a 90s car equals not perfect. And it didn't matter. We had to keep moving forward. You know, I was used to this precision from doing concept cars and, you know, production cars. And that precision just did not work. And what we, as we step through these next few slides, the amount of artistry, I guess, that the body shops have is amazing. Even if you make the most perfect highlight, they're going to skim coat it with you know, with the Bondo or a glazing putty and resurface it. So sometimes, like, I would spend so much time on a highlight, go to the shop, and they would just cut it off or just Bondo right on top of it. And that was something to get used to and to really understand of where that boundary was of where precision's important and where it wasn't. Being a 90s car, there were certain parts of the car that just seemed to not be symmetrical. You would flip the file over to the other side or build the exact same part, and it just didn't fit the same. So that was, I had to loosen up how I worked and rely and basically make a part as good as we could, but knowing that whoever's going to install it and the final fitment is really going to be done by hand. Those initial test pieces, we 3D printed all of the parts, full size, had them shipped from China to the US to do fitment on the vehicle. And this was wild. First of all, they're huge parts, massive crate. We open them up. It was quite obvious they experienced some heat, so there was some deformation right off the bat. So our fitment we knew was going to be slightly off. I had put some what I thought were reinforcement of areas that weren't going to be bonded to the car, and that just wasn't enough. You can see in the front bumper where there's all this tape, somebody dropped the part. Shattered, absolutely shattered, no durability to these parts. But we did learn a lot from that experience. We 3D printed a full body kit, full quarters, the whole thing, and fit it onto the car and got our first look in 3D, or, you know, be able to walk around it to see how things really came together. And that's where things started being, things were obvious that there was issues. The first round of parts, we did an initial round. We made some changes, had those prints, had the files 3D printed again as a plug instead of a body panel. And then from those plugs, molded, parts produced, and those initial parts shipped over here. You can see on the side skirt area, there's like this arch, and the fitment to the lower rocker just was way off. And if you forced it, because we were trying to mold all the detail in to a single part with minimal, basically, control, it would start twisting and bending, and different things would want to flex as you attached it to the car. So we had to rethink kind of how we approach some of the part breakup and how they were mounted. But, you know, we made the changes that we needed to, and we ended up producing a show car. The initial debut car were from these original parts that we modified and did relief cuts on the fiberglass to help it relax. And we did all sorts of tricks, or the body shop did. I didn't really do it. This company, AMS in New Jersey, and they really massaged everything and got our first show car out from these original parts. On the next round, where we were intending to make production parts, this is where a lot of past experiences and just knowing the challenges of what we were facing in China at some of the factories, and how we could make it as easy and simple as possible. I taught myself Fusion 360, and I knew generally what it was and how to use it, import parts and things like that. But really building this lattice structure on the backside of the parts. And what I came up with that was the simplest thing we could do is I made each of the molded parts able to lay flat onto the table. Those parts could be clamped to a flat surface, and as long as it laid flat, we knew at least that part of the distortion was going to be removed in those parts. From there, they would make a fiberglass mold on top of those, and they would add their own runoff and flanges and things like that where they needed to. But really being able to lay those parts dead flat onto a surface in order to help prevent any of the twisting that we were seeing in the original parts, just it went so far. And we probably could have gone further with it. We had ideated about a lot of different ways of doing this. And this was kind of the most simple and easy to communicate of what we were looking for. And it seemed to work out, well, very good. So from that point, we started working with the fiberglass shop, who is a different shop that would actually produce the parts, trying to dial in how much fiberglass, what's the cloth stack up that we're going to use, the process, get the gel coat and the final surface as perfect as we can. And these parts, night and day difference from the first round. So on the left is AMS, the shop that did the original car, and they've done 3 cars since then. And each time the parts are fitting easier and better the first time. So there's less customization or less fitment customization. Then those parts started going around the world. The car on the right, the white one, is Kaiser's car, and I believe that was finished in the UK. And same thing, we followed a lot of these initial parts just to make sure the fitment was good and that they could just lay it onto a fender or a quarter and things would lay straight where they needed to. From there, these cars, the kits have gone all over the world. And it's really interesting that each car that gets produced, somebody has modified something. Some of my hard work, like I'll have a slide for you in a moment. Some of the tweaks and the changes that have been made to these parts are wild. Things I spent hours trying to perfect, somebody just cuts off and redoes it, into their own interpretation. And that's one of the most satisfying parts of this is you get to see how people use these and make it their own so that not every car is exactly the same around the world. All right, so let's see if I can. Let's switch over to here. All right, are you guys seeing Alias? Just give me a thumbs up, maybe Mike. Excellent. So this would be, let's see, this is the initial import of Kaiser's, basically the body kit and the poly model that he brought in. And just to be clear, the initial model is just, a lot of these fan art models that you would find on Turbo Squid or other websites. So the fitment is not perfect to a scan. And as I brought in his data, and for example, it's all triangles because this is just coming in as a FBX or OBJ, I don't recall. But you start seeing where he's cheating a lot of things, massive wheels, the arches are really wide. And it's at this point that I start having to take all of his parts and start fitting them to scan data. So let's go ahead and just have a look at some of this. So here's our initial scan that we had. And this was by a handheld, we'll call it a consumer or prosumer grade handheld scanner, and lots of missing details, lots of things. And so we had to have a lot of very specific areas rescanned in order to get more detail out of it. But this was what we had to work with. And so I did my best to build everything to it. I had multiple positions of the scan because the distortions from a handheld scanner, a lot of times those will have distortions on a large model like this. And so I had to shift things around in order to get different parts to fit correctly through our tests. But, of course, that didn't stop us. The wheels that we ended up using, I built these to the spec of, that we were actually going to produce them, or that we thought we would, in the location generally that we'll need. We had a lot of back and forth of trying to get the right fitment. And the way that came out in the final show car was just absolutely perfect. A lot of times these wide body cars, you'll start with the wheels on and scan it in the slammed laid out position with the wheels, and that way all the camber, everything is correct in the real world. Whereas with this file or with this project, we didn't have that ability to do that. I modeled this just like you would do any other surface model, really paying attention to the highlights and the shapes that look like they were the same as the OEM, so that these parts would just blend in and out of the OEM surface. Here, I'll turn on the poly. So, matching all the little undercut on the doors and really getting the lines to strike through the whole car in like a really nice gesture. The original, our first show car, this front splitter, it was amazing. It was much larger. It was almost a time attack car, if you would. So we took it to the show. We debuted the car. We drove the car home. We were all excited. So of course we're doing rolling shots on the expressway, and it was fun. Put it that way. We get home. The entire front splitter and the bumper had split apart. Snapped all the hardware underneath. Tore some fiberglass. It had so much downforce that it ended up, this little gap that's here ended up splitting across the front, and this piece ended up dragging on the road and things like that. So things, we thought it would be strong enough, and it certainly wasn't. So on the second version, we pulled everything in, and yeah, it resulted with this. Every step of the way, there was some refinement to get the parts to fit better or be more aerodynamic, since we did everything digitally, and it was really our first real test. But it came out really nice, and it's gotten a very good review. And yeah, so that was our LTO E36 project, and really taking everything I've learned from OEMs minus the budget, and try to build these cars completely digital has been quite a feat. Just as a note, at the time, or even now, a lot of people still do foam and sculpt foam and then pull, fiberglass panels off of this. Many companies want to take the 3D prints, work them, like body work them, and then pull molds directly off the vehicle just to make sure everything fits well. Whereas we didn't have that luxury with this, and it still came out really nice.
Mm. So Kevin, that was a really good statement that you had, that a lot of the OEM experience you had helped you with this, but has this then helped you go back to the OEM kind of, well, Waymo's not really a car company, but they are, they do have these needs and standards. Did that help you go, learning what you learned here and going back to more of a structured workflow?
I think it complemented it very nicely, especially at Waymo, where we were relying heavily on 3D printing and the prototyping.
Right.
When you get into production, and applies to everyone outside of Waymo included, it's draft angles, being able to pull a single part, combining pieces and elements in order to make the molds as simple as possible for cost reduction or just time reduction. All of those things ended up being, I sort of fumbled through with this project, and now I can apply it with certainty in the future.
Got it. Okay.
Yeah.
And then secondly, one of the other questions came up was, you said that you did a lot of this work pre-sub Ds, but if you had this work to do again and you had sub Ds, what would you do differently? How would you approach it differently?
So we do have a project that is on hold at the moment, but we did 80% of it in sub Ds.
Mm.
And because of the level of body work that happens by, an auto body shop, sometimes like Part Shop Max, he's somebody on Instagram or that builds parts for drift cars. He's doing a lot of sub D work, straight to parts, all vac form ABS parts. He gets, we've talked about reflections and controlling reflections. And the reality is when you can get 90-95% of a reflection. When it gets applied to the car, fitted, and somebody else is fully working it, a lot of the subtlety just gets completely lost. So, when you're blending, for example, like in this file, trying to be very controlled of how you blend different lines and character lines out, you just don't know who's going to work that area. And I mean, they may sand a lot of that detail away, or if there is a wave or any sort of defect, they're just going to block it to remove that. So SubDs lends itself to this type of work very nicely because you can build quickly, you
Yeah,
can get to rendering fast, and at the end of the day, people expect to have to work the panel. And it's not like a restoration panel, or well, even with a restoration panel, old sheet, old new, or new old sheet metal,
sure.
all that stuff still needs to be reworked. And that's what's really nice about sub-Ds and why we would probably approach it more heavier in the sub-D side.
Well, okay, good.
Yeah.
Um,
Now one note, fitment and measurement and deviation and gaps and all those edges, that's where the level of control, I have a method, just from working in production environments and OEMs, I know what I'm measuring and how much I can deviate. And whereas with sub D, sometimes that stuff's a little harder to control. Uh,
sure,
so blending NURBS and sub Ds would probably be the way to go.
got it. One of the other questions
And
that
then
came
one
up,
note on that.
go
Now,
ahead, sorry.
Kaisel works in Studio Max, and as many of you probably are aware, in poly modeling tools, you can get away with 5-sided polygons or 3-sided. You can get away with a lot of different types of sub-D structures, right? And it will just give you something. Whereas Alias is a little limited in the types of surfaces it can input and reinterpret to a sub-D. And that would be the one thing that is very nice on one hand, but then like working with Kaisel has to be hyper aware that he may be able to produce something in Studio Max that I'm not able to reproduce inside of Alias. And knowing where that boundary is would be important if you are working,
Mm.
multiple people on a single part.
When you were exchanging data with Kaisel and you sent data back and forth, did you do FBX or what was your file format that worked best for you guys?
I believe it was FBX. FBX and OBJ have always been the best way to go.
Got it.
I can't recall which one. I think it's OBJ. The way it groups and merges meshes is different than what you would expect. And
Okay.
sometimes it's like one direction, it just makes the whole model one giant mesh, and it makes it difficult to break that up into individual parts.
Got it. Got it.
But Alias especially, and all of Autodesk data translation has come a long way. And
Yeah.
now we're exclusively sending stuff back and forth from FPX. So
One of the other questions was, what other tools out there, other than just the Alias or Autodesk suite of tools, would you use if you had this to do again? If you're starting up a new program, would you uh, bring in tools like Blender or Modo or whatever? What other approaches would you take?
Blender, if I didn't know Modo, I would be using Blender for sure. That's would be a given. Blender is an amazing tool set, especially for the modeling side, that you can create a lot of things with a good rendering interface to be able to generate this stuff. Now, Kaisel, one thing that's unique with Kaisel is he's basically looking at his model fully rendered all the time. You
Mm.
know, inside of Corona or inside of Max, being able to have a viewport of the Corona render. And so when he's looking at shapes and stuff, he's seeing a fully rendered, ray traced or global illumination rendering that looks finished. When he looks at Alias and I'm modeling, he's like, what am I even looking at? there's no reflections, the shadows are fake,
Sure.
everything's just not as high fidelity. So products like Blender and that really helps because you see that what the finished render is going to look like from the start while you're working, basically.
Got it. Yeah.
Um, there would be no reason, yeah, I know Alias, so that's the best tool for me. But if somebody was doing this per se, let's say in Rhino or Fusion 360 was used to do the E30 LTO body kit. Fusion 360 was used to do the Label Motorsports, I think is the name, the wide body C8. So that's a very powerful tool as long as you know how to use it. But those
Got
two
it.
tools would be the other features that would be very helpful.
Got it.
Um,
One of the other questions is how much CFD work was involved with making these models? I mean, did you do any analysis or did you do any wind tunnel stuff or whatever?
for this, no.
Okay,
It just had to look the part. We
right.
probably could have used that for the front splitter. We did switch, instead of having molded in side skirts, these extensions, the black sections here, instead of having those molded in, same with the front, we had originally a carbon mold for those. We ended up using expanded ABS. You buy it in sheet and then have it routed. We did use the
Mm,
CNC router to cut those out because we wanted them flat. The front splitter goes, halfway under the front wheels, basically, pretty
yeah,
far back for a flat bottom. And we found that it was cheaper and easier to keep those sections perfectly flat by CNC routing those.
got it.
But we did not do any milling for this project. This was a 3D printed plugs and part kind of setup that we had.
Yeah, it's cool. Interesting. All right, so that's it on the questions in the chat. I'll open it up to the group in case you didn't see my message to put your questions in the chat. If anybody just wants to fire off some questions for Kevin, that would be great on this subject, Kevin, and then just kind of anything that you kind of talked about, right?
Sure. Yeah.
Yeah.
Hey Kevin, Steve Jones here. I haven't seen you in a while.
Oh,
How you
yes.
doing?
Very good.
Good. I have a question about a very interesting project. First off, this is fantastic. So I was curious. Very nice Alias model as always. So you imported the Alias into the Alias data you made, and you imported that into Fusion. Then in Fusion, you made a female cavity mold in the end for the production parts, if I understand correctly. And
It
then you
would
made
be,
a black.
we made a plug, a male plug would be it.
Okay.
Yeah. Here, let
Yeah.
me see if I can flip back to it. But yeah.
And then you made you mentioned you made eventually you made a cavity mold. Is that right? A female cavity mold with lattice
Yeah.
work in this. Yeah. So
Am
that
I
was,
sharing the presentation again?
yeah.
So the white parts on the left-hand side, those are the plugs. Those would be what I guess would be a male plug. And then on top of those would be surface or auto body, primer, 2K primer, sanded, blocked. And then on the right, you would build a fiberglass mold. And you can see like there's a ridge, like probably a foam or a cloth
Mhm.
boundary around that. And that's
Yeah.
just helping extra structure. And these would be the final master molds that we would use to build the parts. Does
Okay.
that
So
make sense?
yeah, it does. Yeah.
And then the white part here on the end, that's the surface quality that comes out of the mold. So we, gel coat, everything's finished, waxed, polished, and then, the parts are brought out. So
Yeah, this is great because in a lot of show cars that I worked on, they use these heavy duty 5-axis mills and high density foam to do these cavity molds, which is a very intensive and expensive process. And this
yeah.
is really effective. I mean, the surface quality looks the same, and you're getting out of a 3D printer essentially.
Yeah,
That's
I
fantastic.
wish I couldn't find these photos. So we had some options with 3D printing. SLA is a resin printer, right? So you can get really fine detail with that. A nozzle FDM style printer, you get a lot more ridges that you have to fill in and sand, whereas the resin-based stuff, it's really quite good quality. They make large printers, but the problem is the parts will cool at different rates and they have shrinkage. And so you're introducing distortion. And so what they would do is they would cut these panels up, maybe like 3 or 4 kind of vertical pieces, and then print those all at once. And then they had, hard to see in this image, there's some seams with like these clips that they use for alignment to reattach them. And so that's how we were able to print these big parts as from multiple small ones and then reattach them at the end. So
Great.
yeah.
Thanks, Kevin.
Yeah, no, thank you. Great question. And then just things that we did explore, because the plug is really important that you keep it stable, and you don't want to introduce any flex or twists. Anything that's in the original plug will be in the final part. I probably would have gone even more of this lattice structure on the back, knowing just how critical that was. Originally, we wanted them to use either wood or steel. Let me take a moment here. The first molds that we got back that we did not have this, they had basically glued to a table all these sticks. They look like paint sticks or bamboo sticks, holding the different parts stable, and then glued it to this table. And it was very scrappy. It was great. But because of that, parts were flexing and not perfectly twisted or still and things. So we had to come up with a way. And I originally wanted them to make a frame, like a fixture, that they would screw our parts to, and that would make sure dimensionally it's correct. But that was just too much to ask for what the factory wanted to do. And so the more of this lattice structure we found, the better, because we at least had confidence that we knew what we were getting. And then we had measurement points that we spec'd out on a sheet that they had to measure and show us the measurement from one point to the next to verify that it was square. And all that stuff, just helped out a lot. So great question. Yeah, the engineering foam, or the what's the name of the foam? Like Ren shape or Ren board. That stuff's extremely expensive, very heavy, and to the point where you almost need heavy machinery in order to move it around. And because we were moving factories in China, who was doing our 3D printing was different than the molding and the parts. And so that was our biggest limitations, is finding a resource that could handle everything under one roof.
Mm.
So.
Cool. I've got a couple more here, Kevin.
Yeah.
One of the questions was why 3D printed plugs versus milling MDF, etc. Was it cost and speed, or was it something else?
The biggest thing was the fact that we had different factories. We didn't find a factory that could do all the same stuff in one house.
Okay.
There would be a milling place, and then there would be a body or a composite place, and they weren't the same. We have played with MDF molds, and a lot of the MDF, you'll do like a rough cut, and then you can saturate the MDF with like an epoxy or some sort of resin, and then put a finish path on the resin saturated MDF. And that gives you a really good finish, or a much better finish than just the wood. But again, it's heavy, it's dirty, multiple parts, and steps. Some of the show cars and things, they'll do an MDF rough and then spread this, basically, let's just say it's like 25 mils of this paste that is the hard foam, and then you'll surface that. So there all are alternatives, and it's just really the level of commitment to the equipment and the finish and what you're capable of. So
Got it. Do you see this approach, what you guys did, as far as your back and forth and design? I'm assuming that not all of you were in the same location. There was a lot of remote work.
Heisel is UK. I was in Brooklyn at the time, and Eric is in New Jersey. So, and then
So
everybody else was in China.
did
So
you feel that that was as efficient as being all in the same place all the time, or more efficient or less efficient?
the number of samples that we had to have air freighted from China to the US was probably absurd, but we
Yeah,
really wanted to dial the process down. We weren't going off. We felt at least that we were doing things for the first time. And a lot of the places we were working with were doing stuff for the first time. And so, we were kind of making it up as we went.
sure.
Now, since then, if you guys are on YouTube, Industry Garage did a carbon Z this past year for SEMA, and they 3D printed their parts, and they did vase mode for 3D printing on a lot of the stuff, which just basically is the extruder goes around in a circle until it makes the part with big flanges on it. So they look like open boxes, and then those flanges they would use to glue together to panel bond them. And it was quite a great way to do it. They did it right in their garage in Baltimore. So it was very cool to see how people are interpreting,
Mm.
this. So one thing that, having the background of knowing how precise CNC and tooling foam can be, I was I was skeptical with the 3D printing for how like confident wise, confidence that it's going to be exactly what we ship over. But after seeing the final process at the body shop, it was like that doesn't matter. You know? It's like sending a project over to advanced projects or prefix. Like you're going to get a beautiful part back. You know?
Right.
And
But
so
it may have handwork involved.
yeah, like so this car, the red one, for example, was the second one done by the same shop. And you can see in the rear, just above the tail light, it's fully molded into the sheet metal as it wraps around. The kit was not built that way. He moved the black edges back a little bit to give a little bit more space. Like there's a lot of little subtleties that they just rework. So if things are slightly off or they're not perfect, the body shop's going to make it perfect. And
Mm.
and you see that with like RWB and Pandem and all the other body kit companies that they really rely on the skilled um, trades, to bring them to that next level.
Got it. So one of the additional question, Kevin, was how would an SLS with nylon compare with a large scale 405 NM resin SLA?
I specifics I'm not familiar with or not sure.
Okay.
And for the
Just
SLA, we told them the properties we were looking for, and they chose the resin for us. We didn't have much input in that. Um, Basically, we approached them with what we're trying to do, explained the quality level, and then they took care of everything on the back end.
I see. Got
And
it.
I just wanted to like add a question on that would be like the 405, the resin that they would have used, was it like more brittle when you kind of got the parts?
So the first parts were brittle, and you can see if I'm still using the presentation. So where was the one? Oh yeah,
It was
sorry.
early in your presentation. Yeah, there we
Yeah,
go.
you could
Yeah,
see the tape.
yeah. Okay.
Yeah.
It completely shattered. It was a sad day for a moment. But the best part is these parts were stored in a shed, and then they had like some 90-degree weather, and the parts completely melted. You know? So whatever resin we switched the resin after this, after we had the feedback, but it didn't work well. So, but they were brittle. Now, if we weren't shipping them and we had some continuity between where they were produced and where they were molded, that would be it probably wouldn't matter as much, But we wanted to see how they would fit on the car as a 3D print. So these pieces, by the way, I think they're just over 3 mils. The thickness, because that's
Mm.
generally what the thickness of the fiberglass was going to be.
Okay.
And And at the end, we even went, I think we went 5 mils or 4 mils for the final parts just to get that extra durability on them because the fitment didn't have to matter. Didn't matter at that point. We could put it onto a panel, you know. So
Cool.
yeah, great question. I mean, this process, there's companies now that are advertising mold, you know, basically that you can print your molds and do the female cavity side, and you know, all sorts of new tech is coming out. 3D printing and then finishing that with a machine to get the
Right.
surface that you want. All these things are happening. And there's a company in Georgia, Massivit, that they cure the resin as it comes out of the nozzle. And
Mhm.
so it's not like a temperature type of thing. It's, yeah, I think it's like a UV, or I'm not
UV,
sure
yes.
exactly. But anyway, that they can do massive parts quickly, and then you can machine those to the final stuff. So if we were to do it
Interesting.
again, we would probably explore other technologies just because we're on a roll.
I would, it's just a small recommendation. If we look into SLS nylon, that would be a great alternative to SLA.
Okay.
There's a company called Rice 3D that does a lot of also SLS, but with metal that can do post finishing on a like CNC or any kind of material like that, or any CNC work is also possible with metal SLS.
Oh, that's amazing. Thank you
But
so
they
much.
are heavy.
Yeah. Yeah, I worked I had just a couple weeks at Divergent 3D before they changed the name recently, but that was wild. You know, all the 3D metal printed stuff.
Yeah.
Absolutely incredible.
Kevin, one last question. As far as the work you did for your group here, did you ultimately did Salim sell the data and then the person, the end user would buy the data packet and then have everything printed themselves, or would you do all the work, including build the skins and just ship them the kit?
For this, we ship them final kit in either fiberglass, FRP, or carbon. So
Okay,
we can do
got it.
both in the same facility, and same molds and things like that. So it's a
Got it.
final part that you would receive.
Got it.
Minimal instructions.
Minimal.
No, it's
Um,
pretty self-explanatory. We tried to make the flanges, everything's kind of oversized so that you can always trim it back
right,
to get the fitment and the shapes that you're looking for. So
got it. Cool. Well, listen, man, it was really good. Loved it. It was very, very interesting. And obviously, we're seeing this as a trend. One of the things that we've been seeing through our business is not just your standard OEM kind of approach to things, but a lot more of this kind of hybrid work, right? This kind of small, low volume, but vehicle personalization. There is an ultimate market for that, and certainly a lot of the startup EV companies have to do things this way, right?
yep,
They may not have the budget, they don't have mills. I don't think Waymo ever had a mill for the longest time. They may still not have a mill. So a lot of companies just decide they'll just do the approach you have, do the design reviews with headsets on in VRED or whatever. So this is definitely trending as far as getting things done faster and with less investment, right?
absolutely.
Yeah.
Absolutely.
All right, guys. Well, listen, thank you so much for everybody who attended. There again, one last reminder, will be recorded. I'll send it out to all the folks who signed up. And yeah, you can take a look at it. And Kevin, did you provide your email or contact point just in case somebody wanted to get a hold of you? I don't know if you did, but if you don't mind, if you can just either say it or put it in the chat, that would be great.
Yep. I'm dropping it in chat right now.
Okay, cool. Yeah, I'll wait till that queues up so everybody can see it. And then we'll conclude.
Excellent. Well, thank you, everybody. It was an honor to be able to share this project with you and some of the backstory. It's
Thanks,
great.
Kevin. Appreciate
Awesome.
it.
Yeah, no
All right.
problem.
Take care, everyone. Bye.
Sure.